Alright, y'all, so we's gonna do some math with a sector and a cone and some derivatives because that's gonna be fun. Alright, so here we go. First it says letter A. Show using the sector that arc AC, so that's this right here, AC, is equal to theta pi over 18. Alright, so first thing we got to do is we know that the arc length is equal to theta times r, but that's when theta is in radians. Okay, now in this situation, theta is not in radians, theta is in degrees, so we're going to have to turn the degrees into radians. And so we're going to go theta over theta times pi over 180. So we're going to go L equals theta times pi over 180, and that should then turn it into radians for us, because that'll take the degrees times pi divided by 180, and of course times the radius. From here we should be able to just plug it in, and so we're just going to go like this. Theta is still theta pi over 180, and r of course is 10 because that's the radius here from A to B, and so that's the radius of our arc. And so we see that that cancels out, leaving us with theta pi over 18. So that checks out. Okay, then it says explain why r equals theta over 36. Okay, now this r right here is referring to the radius of the base. Now that's this one right here. So that's r that we're talking about. Now h is the height of the cone. So there's our r. And you'll notice that r is the radius of this circle right here. Now if you can imagine, if we take this sector right here and we bring A and C together, then this point right here is going to pop up. That's going to be our cone. And so AC, from this all the way around, that AC right there, that's going to be the radius of the base of our cone. And so to get the circumference of the base of our cone. So to get the circumference of a base of a cone, we go, so this was A, this is B, we go 2 pi r. So 2 pi r is the circumference, and the circumference is AC, not AA, AC. And so AC is the arc that we just found up here. And so we're going to say 2 pi times the radius, which is the r, equals theta pi over 18. And so from there we should be able to solve for r. We're going to divide by 2 pi, and when we divide by 2 pi, or pi times 1 over 2 pi, we notice the pi cancels out, and we get r equals theta over 18 times 2, which is 36. I'm sad I don't get to say theta pi anymore. That's kind of a fun thing to say. You try saying it. Say theta pi, theta pi. Alright, anyway, on to letter C. C, show that h equals the square root of 100 minus theta over 36 squared. Okay, well, I need to find h, and it needs to be in terms of theta. Okay, well, here's my h, and I just did this thing with r. So if I can find a relationship between h and r, then that will be really nice. Now, I do have a relationship between h and r. H and r form a right triangle with the edge of the cone, being 10 centimeters, because that was the radius right here. So that will be from the tip of the cone down to the base of the cone. It's 10. So we can now do letter C, which is just Pythagorean theorem for our right triangle. So r squared plus h squared equals 10 squared. And of course r squared is theta over 36 squared plus h squared equals 100 squared, 10 squared, sorry, I was thinking ahead of myself, is 100. So I'm going to subtract the theta over 36, which would be h squared equals 100 minus theta over 36, which is almost as much fun to say as theta pi. And then we will take the square root, and magically we get what we're supposed to have, which is 100 minus theta over 36. squared. All right, so there we go. We've done letter C. Now we're up to letter D. Find the cone's capacity, V. That's the volume in terms of theta only. So now we're going to find the volume. So volume is equal to pi r squared h. Now that's for a cylinder. For a cone, it's actually going to be a third of that. So that's your equation for volume. If you didn't remember that, that's actually in your little equation booklet. And so not to worry, that will be given to you. So from here, I'm just going to write it out. Volume equals 1/3. So this is letter D. 1/3 times pi times the radius. Now the radius was theta over 36 squared, because it's the radius squared, times the height, which is this right here. So times the square root of 100 minus theta over 36 squared. And so now I have an equation in terms of V. So now you can use technology to sketch the graph of V. So you should be able to plug this into your calculator. I'll go ahead and plug it into my calculator right here. And so no, I don't want to update. I just want to graph the stinking equation. So let's move it over so we can type this in. So we're going to go 1/3. Okay, so I'm going to pause the video so I can type this in real quick. You don't need to watch me typing this in. Very well, let's continue. So I've got 1/3 pi times x over 36. Now the x is my theta, right? So x over 36 squared. And then square root of 100 minus x over 36 squared again. Now, before I do this, I'm going to go to my mode and make sure that I'm in degrees. Remember, theta is in degrees. So I'm going to put it in degrees. Not that it matters because I'm not doing any trig, so I guess it doesn't really matter. But let's go ahead and graph it. And it's going so slow. Okay, now remember, degrees are going to go up into about 360. We're looking for theta when the volume is a maximum. So I'm going to actually change this because theta can be anything from 0 to 360. So let's go to the window. We'll say that it can go from 0 to 360. And we'll just make the scale about 90 because that's easy to work with. So we'll go graph. Ooh, there went the graph. It just left. And that makes sense because it's about 10. So let's increase our window a little bit. So we're going to go increase. We don't really need a negative volume. So let's make our maximum volume, oh, I don't know. Let's go up to about 200 and see what it looks like. Oh, there it goes. Oh, there it goes. Oh, it's still going up. That sneaky little line. He still goes up over there. Oh, and then it comes down. Okay, so we're getting closer to our answer. Let's go ahead and go to the window and make y a little bit bigger. I don't know what it is. Let's just go up to 400. And, oh, there we go. Yeah, this is looking good. I like this one. No! Okay, just barely. Just barely went off, and that's okay. So we'll just make one final adjustment. We'll go up to 450. Alright, so now we got it graphed. It wants us to find theta when v theta is a maximum. Alright, and so that we can easily get using our calculator. Since it's asking us to use technology to graph it, I'm going to assume that we can probably use the calculator to get the maximum. And so we just need to go to the left. We need to go to the right. Come on, this thing is so slow. Go faster, faster, faster. Okay, there we go. Oh, I went too far. Awesome. It's just still going. Okay, turn off. Stop. Ah! It doesn't want to stop. Oh dear. What have I done to my calculator? Anyway, you know how to do that. So, sorry about that. I don't know what's wrong with my calculator. It's going to make me cry. So, go ahead. You can finish finding the maximum. If you want to, you can do it by hand. It's going to require a product rule. So, but I think it's okay if you just use your calculator for that. Ciao.